Thank you. Thanks.
You're smart.
And then I programmed a fourth. You ever heard of that language? Fourth?
No.
Yeah, it kind of died somewhere along the ways, but I programmed a fourth compiler in BASIC, and man, was that slow. But it was
Actually,
cool.
It tells you coded in Fortran.
Oh god, no, I never learned Fortran. Never learned Fortran.
It'd be hard.
Yeah, it seems like it would be. I know C pretty well, but
C's nice.
yeah.
Or C++. I don't use.
Yeah, anything where you can overwrite the memory where your code lives is fun.
Yay, memory management.
Yeah.
It sure doesn't break. It's like the one thing I hate most about C++.
Yeah.
It's the most
Oh
annoying
yeah.
part of it.
Yeah, Malik.
Yeah. Malloc error every single time.
Absolutely.
Every single time.
Absolutely. So I kind of like, I'm trying to keep it together. I actually found out some bad news about, honestly, I can't even talk about it, but Camila was there. But I kind of just want to like do some stuff and roll. Sorry, I don't mean to bum you out, but I'm feeling like just on the edge of like losing it. So it's not about me, it's about our little, I can't even say it. Let's do, this should be a fun class, huh? Okay, yeah. Let's do some fucking partial derivatives. Yeah.
That'll cheer us up.
Yeah, it actually will, it won't hurt.
Yeah, it's pretty easy to look at.
Math's always good, I've always come here for refuge from
In the real
the
world.
suffering of the world, yeah. So let's just do some, actually I kind of want to just introduce, stepping this up a little, and I created a web work. So there's a web work that has partial derivatives first order, which is what we talked about, just level 1 derivatives, and then second order, where things become more interesting, because we can do x first, then y, xx, and so we've got 4 different levels of second order partial derivatives. So let's just talk about the notation. So last time we had first order. So the first order, derivative, partial derivatives. So we've got a function f of x, y, and we can say that. I'm just talking about the notation here. That. So let's just make sure we're clear here. And actually, let's do something here. So z equals that. So I could also talk about z sub x as the same thing as this. So notationally, this would mean that, And then I could have z sub y, which is f sub y, which is the partial of f with respect to y. And you know, if this thing had more variables, in general, I might have something like this, w equals f of x1, x2, x3, all the way up to who knows how many independent variables. And at that point, I could have partial of f with respect to x sub I, any one of those guys. So it's the same game, right? Once you got this level, you're good with all of the levels. So let's talk about second order partial derivatives. So same old function, we'll just kind of think about this from the perspective of f of x, y. But as I said before, you know, it could extend up further in terms of the independent variable count. So here, let's just introduce some notation. So if I have second partial of f with respect to x of f, then this would be notated f sub xx. And here, this can be confusing. The first one is the first derivative, and the second one is the second derivative. And right now, they're the same, so you can't really go wrong. But this is the partial with respect to x of the partial with respect to x. So do this first, then do this. If we have f of x, y, then that means do x first, then y. So this is kind of weird in a way, because it's you would feel like it'd be functional notation, but what it really means is like this, partial of f with respect to x, then y. So that one is the second partial of f with respect to x, with respect to y. So here I've got two of the del symbols, and then I've got f here. And let's just get some terminology out here, just so we know how to say these. This is the second partial of f with respect to x. And if you say that, it seems like it's clear that it's xx, but this one here is the second partial with respect to x then y, which gets a little just easier to say f sub x, y. As long as we know we're talking about derivatives. And then that fxy could have gone in the other order. So we've got fyx equals partial of f first, with respect to y first, then x. And that is the second partial of f with respect to y, then x. Say that in the reverse order. And then the last one, so I said there was 4. This is second partial with respect to y. So notice that we've got the squared notation from second derivatives in calc kind of just coming through, except that the only difference, like this just looks like it could be d dx, d squared dx squared, but here you get a little bit of a twist on it. Then if you wanted, you could keep doing this. You could go up, we're not gonna probably do it because there's not a lot of need, but notice you could go to higher orders. So let's say I had f of x, y, z, and let's call that w. Then I could talk about things like this, w, x, x, y, x, z. You know, so this is the 5th order derivative. X first, then y, then x, then z. So this would be notated 5th partial of f with respect to x, and then probably square that. Let's see, do I get the square? Yeah. And then partial with respect to y, partial with respect to x, partial with respect to z. We're not gonna get that crazy, but that's cool to think about, you know? It's nice. So one thing you might wonder about is how different is this from that? So partial with respect to x, then y, partial with respect to y, then x. Are those different things? And the answer is not always, but we have this thing called Clairaut's theorem, which basically says you have to try really hard to not make them the same, but they can be. Think piecewise defined shenanigans, like I was saying. Like that's how you create trouble in math for the most part. So Clairaut's theorem says, given f of x, y, if f with respect, partial with respect to x, partial with respect to y, partial with respect to xy, partial with respect to yx are all continuous in a region, and probably here, I think probably we also want these guys here too, these other pure partials. These are called mixed partials, these are pure partials, are continuous in a region are containing point A, B, then f with respect to xy of AB is equal to f with respect to yx of AB. You gotta try hard. You gotta really try hard to make these things messed up. So it's this here, this expression, continuous in a region, when your derivatives are continuous in a region, we would say that f is actually an element. And by the way, look, indigo.
Yo.
Got it. I realized I had a whole box of them at home. So not just indigo, but all the colors is C2 in the region R. So this means continuous second derivatives in that region.
that symbol mean again? That's right after F.
Oh, sorry, that is element of, or it just means in this set. In the set. That's how you can just read it, Daniel. Does that make sense?
Yeah.
Yeah. And then this is just the collection of all twice continuously differentiable functions. And basically this little phrase right up here. Is that all good? No? Okay, cool. So again, don't worry about this. For us, you can do these in either order, and you're gonna end up with the same answer. So knowing that, and then just refreshing your mind that there's some web work to practice, what would be cool is this weekend if you practiced on that web work. Like checked out those web work, did some of those partials, and then on Monday we could talk about it if there was any troubles. That would be great, because we're meeting Monday and Wednesday of next week. And part of me was thinking, should we what do you guys want to do? Do you want to knock out a skills check on this stuff before break, or do you want it to kind of sit? Christian's saying yes, but let's listen. Kayla's saying I don't care. What do you all think? Should we just do a skill check, some skill checks on Wednesday? Because you get to redo them anyway, right? But then it gives me, so then you want me to have work over break, right? I'm gonna give you work over break. So let's actually switch to pink for positivity.
There's my pink. It's on the board.
What's that?
Oh, it's on the little
Oh, thank you. Oh, I've got extra. I brought 2 of each. Thank you. Oh, that is pink. Thank you. Thanks, Daniel. So here's kind of the plan then. Let's just talk about it. So practice partials on the web work over the weekend. This weekend, I'm barely able to compose sentences. This weekend, or write legible symbols. And then on Monday, I think what we're gonna do is we're gonna talk about tangent planes and the gradient. And the gradient is a really cool gradient. The gradients are real. Has anybody ever seen the gradient before or talked about it? Let me show you the symbol. It's that symbol right there.
We just talked about it in the last class.
Yeah.
Did you, which class?
And
Oh, really? Cool. Awesome. Okay, nice. So do you use that in Chem? Do you use that in Chem? No, not really. No. I bet Dr. Jean does though. I bet he, yeah.
We
I
use
bet
it
he gets
one and two, don't we?
Yeah, I was wondering if we did do it in quantum. Use that in quantum.
I bet you did
Probably.
this in quantum.
Yeah, maybe.
Because that's the Hamiltonian.
Oh, is it?
Oh, we just use like
It's
H
the-
hat.
Is that some of the second pure partials? No? Yeah, we'll definitely check it out. Cool, so then on Monday we'll do this and the gradient and talk about what those all mean. And then we'll do some skill checks on Wednesday. That's okay with everybody then? Okay, awesome. Friends watching, look. All right, so then let's do some practice together. I think I made a little sheet with some stuff I wanted to practice. Oh, and in our world-class shell, in the content area, I put the greatest calc formula sheet ever created. If you've had calc with me before, you have already received this. Check it out. It'll be great for not just calc, but all your math. It's got literally everything you could want to use. Trig, geometry, all sorts of really cool stuff in it. So let's find, so here's gonna be the game. Find all first partials, and then I don't have to keep writing it out. So all the first ones, and then this guy, and I'm immediately going to be wankerous. Put that out there. Anybody remember the general formula for the arc? That's arctan. What's DDU of arctan of a constant times u? Do we remember that?
the derivative of arctan. I don't know what that is. I don't know what the derivative of arctan is.
So you're thinking chain rule. Okay,
Yeah.
that's cool. That's cool.
So
Yeah.
we can get out of
Do
that.
with arc seeking. Okay.
It's actually much more beautiful. So it's like a good one to know. I like Daniel's plan. Let's start with the simple version and then chain rule it, just so we can practice the chain rule. So recall, I'll put that in quotes. Recall that ddx of arctan of x is 1 over 1 plus x squared. Good one to know, really good one to know, because this is if you were to ask to integrate this, then you can come back to that, right? The integral of this is that right there. So ddx of arctan of AU is going to be, as Daniel said, derivative of the arctan with the inside left alone. You didn't say that part, but I know you meant it. So that times the derivative of AU, which is A. So it's A over 1 plus A squared U squared. Go forth and conquer. There might be another chain rule required in there as well. Start off with showstopper. Right? Oh, you got stuff. You got some stuff. Awesome. Damn. Yeah.
I wonder if I could simplify it.
You could definitely. So that would be an awesome. That would make me happy.
Right.
There's pretty simplifications that can happen.
Those two not equal, or
I'm sorry. What? I just rewrote this.
yeah.
It just because I honestly it'd be less painful because you don't want to use the quotient rule if you don't have to, right? I haven't done the really mean thing that I'm probably gonna do. When you're suffering, nothing helps like making others suffer. That's the one thing I've learned from all my meditation over the years.
You should be a politician.
And then just like pretend I don't suffer.
Yeah.
Yeah, exactly.
Pretend to suffer so you can get lots of money.
Oh my God, I'm so fucking sick of those people right now. I was losing my mind this morning and last night. I ordered some posters from the Satanic Temple for my door, my office door today, so that'll be fun. No, they're good. The seven tenets of the Satanic Temple are like what everybody should live by. They're just beautiful things. And those guys, just by the way, I don't believe in Satan. I believe in humans. You don't need to believe in Satan with humans around. I do believe in the work the Satanic Temple does at fighting nationalist religious movements. So up. Now that's all on recording. That's good. All right, I'll just do one of these here. I'm gonna call this Z for the hell of it. And I'm not against your spiritual beliefs until they get made into law. Then it's a problem for everybody. Okay, I'm gonna stop. I'm going to stop, I promise. So let's see here. So I do the outside part first. Like that. So I'm just leaving that inside part alone. And that's the guy that goes. Is that cool? Do you see what I'm getting at there? Yeah. Okay. Cool. And then. Let's see, then times partial with respect to x, and it might help to slow down and just do the notation bit by bit. It kind of always does. So then this is 1 over, and I'm gonna break that apart right there, because I made Daniel rewrite it. So I think I should have to rewrite it too. So then that's, and let's do two more rewrites. Y squared over x squared. And this is the stuff that helps me emotionally doing this algebra here. So this is good. Any questions I'm getting here at all? And please make sure I'm doing it right.
I'm just confused where the negative came from.
That came from the derivative of the x to the negative 1.
Oh.
So thinking about the power rule. Does that sound good, Brandon?
Yeah, got it.
Got it? Awesome. Yeah, so the negative 1 came out in front, and then the x went to the negative 2nd power. And then I want to multiply this x squared times this whole denominator, and I'm going to bring the y times negative 1, so it's negative y over x squared plus y squared. Holy smokes, that's pretty. Sound good? Is that what you got when you simplified?
Yeah.
Awesome. Oh yeah. Oh yeah. I'm sorry you guys have to hear all my rants and stuff. I really hope I don't offend anybody in here. I don't intend to. All right, let's do the partial with respect to y. And so like that, this part's going to be the same. So that's kind of cool. And like when I say that stuff, I can't see your faces, so I'm like, everybody's really quiet. Oh my God. Shit. Dr. Jean and I are always on the same page about this shit. I'm gonna throw him under the bus.
We haven't gotten one of his satanic rants yet.
Yeah, do you have it?
No.
No.
We get rants about his ex-wife a lot.
Oh, God. That's true. Oh, that's the highlight of my day when he does that.
Oh, really?
He's so funny about it.
It was pretty funny.
It's so funny.
I remember when he was married. Yeah, no, he's smarter than me, and he doesn't talk about it in public. So, yeah, let's simplify. Is this cool, first off? Everybody see what I got here? Okay, awesome. So, this is actually, I'm gonna leave this on top for a minute, and I'll show you why, because I think it's gonna make the algebra easier to understand. Because what I'm gonna do is multiply the bottom by x squared and the top by x squared. And it'll just make it a little easier to simplify this thing. And we want to see the beauty. And the thing to keep in mind is these partials, I mentioned it the other day, you're gonna see symmetry. Look at that. Isn't that nice? Let me stop and let you take that in.
Why did you multiply it by x squared over x squared?
Because I wanted to clear out this complex, because I've got a fraction within a fraction. and then to get rid, I just don't like fractions within fractions, and in general, they're easier to work with when you don't have them. So I multiplied through the bottom by x squared, because I knew it would turn this into just y squared. Does that make sense? Cool. Any other questions? No? Okay, while we're here, find the second partial of that z. So do me a favor, find zxy. And you could go with zyx as well. So somebody, you tell me which one you're going for and I'll do the other one. I kind of got a feeling I know which one you're gonna go for, the one without the negative, but maybe not. What were you doing, Daniel?
I'm doing ZXY.
ZXY, awesome, cool. So it's got the negative in it. I'll do ZYX, but probably everybody started on this one. I'll do this one and we can compare at the end. So remember, that's the partial of that fraction there with respect to x. With respect to y. And it makes you really grateful for the simplified form too, right? Not having the fractions within fractions, because that'll just be just atrocious. These turn out to actually not be very bad at all. We're gonna see awesome sameness, ideally. Don't FOIL out the denominator. That honestly makes things further from good usefulness. When you have something factored, leave it factored, as long as you can. Maybe I'm gonna make this recording private, just send you all the links to it. Is there a question, guys? Is it good or you got it?
We can go through it, because we.
Yeah,
we all
totally.
got
I'll go
different
for it.
answers.
Absolutely, absolutely. Yeah, so, would it help if I did this one? Or is it
I did
specifically
that
this one?
Yeah.
Okay, we'll do this one. So, take the partial with respect to y. I'm gonna differentiate that with respect to x. So here x is my moving part, y is constant. Quotient rule says derivative of the top, 1, times the bottom left alone. So I copied that there. Yeah, does that help?
All right.
Minus top left alone times the derivative of the bottom with respect to x. And since the y is constant, that y squared just goes to 0. So I just get 2x for the derivative of the denominator with respect to x. Athman, you good on that? Yeah, cool. And I'll stop before I go. And then the bottom squared. So I just copied the denominator and put parens around it and squared it. Better.
I just like missed a couple.
Easy
Signs
enough, easy to
stuff.
do, easy to do. Brandon, does that feel better?
Yeah, it's already.
Okay, awesome, cool. And then I just simplified the top. This is minus 2x squared. Then I've got y squared minus x squared when I group the like terms. Stuff. Let me do the other one so that you can check that out. I would just pull that minus out in front so I don't have to think about it. Because the derivative is linear. You can pull constants out in front. Do that when you feel like it. for sanity's sake. Derivative of the top is 1. Again, quotient rule. Top, bottom left alone. Minus top left alone. Times the derivative of the bottom. Very similar, right? But I also have this negative out in front. It's similar, it's not exact until I think that remember I got that negative out in front. I got that, like that. And so now, this would become, without the negative, it's x squared minus y squared. But because there's a negative, it's exactly the same as the other mixed partial. Oh, cool. Let me know if there's any, I'm happy to go through, no, I will. And honestly, this one's making, I'm feeling a little better, just like getting into this. And then I start thinking about that I'm saying that, and then what a dummy. Okay, I have one other thing for you to do. I don't know why I wouldn't ask you to do this. Could you find, let's do one of them. Could you find the pure second with respect to x, please? So let's find the xx to practice this, because it seems like something that everybody's there's a little bit of hesitation here. So let's practice with this. Practice pulling that negative out in front, right? Holding that out in front until you're done with the rest of your work. And I would note you don't need the quotient rule because we're doing x again. So let me just point something out here. You could rewrite this like this. If you rewrite it like that, the minus y is just a constant out in front when we're doing the x derivative. And then it's a chain rule action, but boy, a lot easier, right?
We're already like halfway through.
It's cool, I'm sorry,
Well,
I'm
like-
sorry. You need to pull the rug out from under you.
No worries. Still trying to go get some ramen after this? Actually sitting there. Not the whole day.
Trying to slow down on the steps and notate
What's that?
a little more fully. So that's going to be 2x.
It's not like street food cheap. Like I think it was the last time I went, it was like $15 a bowl, but like the bowls was cheap. Yeah, true shit. The place was so good. It was.
Forgot the square on the bottom.
What?
My brain.
Forgot the square.
That's okay, yeah. Did I screw something up?
square.
Oh, thank you. Yes. Thank you, Daniel. Awesome. Good stuff. We good? Feeling okay on that? I feel like one more, even though this is good medicine, just being here with you guys. As long as you, like, one of you doesn't report me and break my heart. There's like that kind of thing always happens like evaluations, like you got this class of folks, you know, like, that was great, I loved all those folks. I think they all love me, and then you read the evaluation, and there's like somebody who's like fucking hated you the whole semester.
It's so weird, just like hold that grudge for so long.
Yeah.
Oh, I know.
So petty.
Yeah. Oh man. Yeah. The worst. There's the worst was like my third year here. I was teaching DiffEQ, and you know how I walk around, and like I'm pretty much about the same as I was back then. Like things haven't changed a lot. It's kind of spastic, energetic, freewheeling, and this one student, like, she had to run out of class once. She like got up and ran out of class. And I was like, what's going on? She's like, it's just, you know, she had like sensory issues, and that's cool. Like some people, like sometimes things are too much. And so I guess I was the most too much she could have. And then I tried to work with her. You know, she had a lot, you know, it's like, what can we do? You can leave anytime you want, you know, step out, all that kind of stuff. And then, oh man, and she like so if you go look at my professor ratings, one of the worst ones, like back, and she even did it like years later. Like was still like thinking about me. Oh man.
Did you only have one class with her?
Yeah.
2 years later, she decided to write about it.
Yeah.
They
Yeah.
should have the
There was
chem
another
professors.
one. One of my other bad ones was some chem student. Yeah, I know it's not. Some chem student who wrote years later about me, like how I often get confused in class, like I'm some doddering. Oh man, like I get off track, you know. But I always know where the track is. Let's do. Sorry, you guys. Thanks. I appreciate you in many ways. So thank you. Let's do some other shit here. So I'm going to say W equals e to the negative xyz. We haven't really done a lot of e stuff. Let's get that in. Reminder that if you have e raised to a function, the chain rule manifests like this. So that's the derivative. The outside of e to the x is e to the x when you take derivatives. So this is the outside derivative times the inside derivative. Always a good form to have ready, especially here, right? So let's find all the first partials, and once you've got one, I think you're gonna like kind of rock the rest. This isn't too bad, but it's good practice. And then let's find these second partials. Oh, and then one more. We'll do a third partial. Just because cool. That'll be it for today. Yeah, I feel good on that first one. Let's make sure, I just want to make sure everybody feels okay about that. Camila, you good?
Mm-hmm.
Cool. sorry, I just didn't, I didn't see a nod, so I was just looking, yeah. Evan, are you good on that one? Awesome. And Ahmad?
Yeah.
Wonderful. So, do you see the rhythm that we can knock out these other ones easily? This one's just gonna be, it's gonna be every letter except this one, so it's gonna be minus xc e to the negative xyz. And this one's gonna be minus xy e to the negative xyz. And then, oh boy, that's cool. What's that, Kayla? What's this next one? Yeah, sorry. Though that flared eye thing, that's usually someone else's, your friend here.
I don't know. My brain isn't working great today.
It's okay.
Y squared, z squared, e to the
Beautiful. Yeah, perfectly. So when I take the derivative of this, with respect to x, another negative yz comes out in front. Does that make sense? Yeah? So you have negative yz and then another negative yz, and like Kayla said, that's just positive y squared z squared e to the negative xyz. And then this one, let's do this one. Let's make sure. What rule do I need on this one? What Calc 1 rule?
Product rule.
Product rule. So this is going to be partial with respect to y. I'll write it out here, of negative yz e to the negative xyz. But remember, you've already got the derivative of the e to the negative xyz with respect to y. You've already done some of the work. You can kind of just snag that, pop it in. Keep parentheses, keep lots of parentheses. They suck in programming languages. They're pretty helpful in complicated computation. Do you want me to do it so you can check yourself? Is that what you're waiting for? Okay, all right. Okay. So I'm gonna pull out the constant, the negative z is constant. Does that make sense? With respect to y, right? So I'm doing the derivative with respect to y, so I'll pull the minus z out. And then we've got, then it looks a little less painful. Yeah? So far, so good, Christian?
No, I messed mine up.
That's, and you kind of knew it. I could tell.
It was not like.
Is this making sense? Do you want me to wait and let you like?
No, that makes sense.
Okay, cool. And then here's where the product rule is going to kick in, right? So we got minus z, and then derivative with respect to y is 1. Leave this alone. Plus y, derivative of this thing with respect to y. So that's that second thing that I cranked out. That's w sub y. And I'll put, actually, I'm going to put it here for folks who are playing along at home, like that. And then plus negative z e to the negative xyz plus y, just copying that. Now I'm just going to copy down what w sub y was, which was negative yz e to the negative xyz. Parentheses, they're sweet, equals, let's simplify. Good Lord, negative z e to the negative xyz. And then minus, so plus y squared z e to the negative xyz. Woo! How's that feel? And so I kind of want to see, oh boy, let's do the last one. So the derivative of this with respect to z. The derivative of this.
I think you must.
What did I screw up?
You put, I think you did dx instead of dy.
Oh shit, you're right. Oh yes, thank you. Because it should be minus xz. Oh,
Yes.
Thank you. Thank you, thank you, thank you. So this, let's copy it here. For those, again, playing along at home, the derivative of this right here is the w sub y. Did I get that right this time? Yeah? So that's the w sub y from right up there. Thank you, thank you, thank you. Cool, and it actually turns out way nicer, right? Because then I get an XYZ collection, and that's kind of cool. So this is going to be negative xz e to the negative xyz, like so. Does that look better? Okay, awesome, thank you. And so then, we can do a couple things here. Let me do it and then let me clean it up because I see something nice that will happen. X from the e to the next, so that times that, and then minus minus gives me a plus x, y, z squared. That times that, that's the z from out there for the squared e to the negative x, y, z. And then let's factor what we can. So I can I'm gonna pull a z e to the negative x, y, z out. Notice when I do that, this is a -1. And then this is just x, y, z e to the negative x, y, z minus 1. Wow. Thanks for fixing that. I think that looks okay. You guys seem on top of this, so y'all seem on top of this. And I kind of want to see what you think about, oh God, and then I said to do it with respect to Z. Maybe not today. What if we did it like over the weekend and we compared notes on Monday? Or not. But let me just ask you something here. So this was WXY. What do you think, looking at the form of this, thinking about symmetry, what might be a guess as to WXZ? So this is WXY. Think about it. Here, XY was the derivative. This is what we got. What do you think the derivative of XZ might be?
Would be like y e to the xz, or like, I guess.
Yeah.
Yeah, okay, yeah.
Yeah, the
And then-
variable that's missing in the derivative
Yeah.
out front. Yeah. And then,
It'd be
Same thing.
that, yeah, same thing.
yeah, and I think that's probably right. And then we could do the YZ in the same way. So just, you know, one of the things I'm saying that for is that when you're doing these, keep an eye out for symmetry. If for one answer you get like XY over x cubed plus y cubed, and then for the other answer, you've got like y sine of x, you know, or something crazy like that, you probably did something wrong. So keep an eye out for symmetry and like, you know, counter symmetry, like minuses with one derivative but not with the other. Stuff happens all the time with these. So I'll do that problem over the weekend, and then I'll just share the answer. That'll give me something to do. And anybody who wants to join me, I'd love to have you folks along. All right, that's good. That's actually like a full freaking class. Look at that. Thank you, friends. Please don't report me.